Hello. Hello. All right. So, mic testing, mic testing, one, two, one, two, three, and smartboard testing. Hello. All right. So, mic testing, one, two, three, and smartboard testing. Hello. All right. So, mic testing, one, two, three, and smartboard testing. Hello. All right. So, mic testing, one, two, three, and smartboard testing. Hello. All right. So, mic. So, recommendation for math. Hello. Hello. Hi friends. वेलकम टू अनदर लाइव सेशन एंड डीक्लटर्ड। आज के एपिसोड में हम वेक्टर्स के बारे में पढ़ेंगे। विल स्टडी अबाउट वेक्टर्स। आई हैड थॉट विल डू वेक्टर्स एंड 3D both together, but vectors in itself is so extensive and expansive that I thought let's get some conceptual clarity in vectors before doing 3D geometry in our next session. I'm available on live chat, so in case there are any questions, queries, or doubts that you have as we go along through the session, please drop in the comments and I will try to pick them up. We have learnt about vectors in 11th grade when there was a bridge course for physics, because vectors is the first and foremost topic taught to us before we start physics. We know that vector is any quantity that has both magnitude and direction. And coming to 12th, we again encountered vectors in maths. Let's pick it up from a maths angle right now. As we already know, a vector is any quantity that has a magnitude and a direction. Direction is nothing but the direction in which the arrow is pointing. The vector as a tail, the starting point, head, the ending point. However, in maths, if a vector just demonstrates direction, there is no starting or end point. It just means that this is the direction of the vector. So, a vector, like we know, has magnitude given by the modulus and the direction given by what we have studied in physics is tan theta. But the first concept that was taught to us in maths was to do with direction ratios and direction cosines. Let's understand what direction ratios and direction cosines actually mean. So if I have orthogonal plane of reference, that is any three axes perpendicular to each other, in our case x, y, z, and I have another vector a bar. Now this vector makes an angle of alpha with the x-axis, beta with the y-axis, and gamma with the z-axis. What direction cosines mean, represented usually by L, M, and N, direction cosines mean cos alpha, cos beta, and cos gamma. And the point of this, or the relation, is L square plus M square plus N square is equal to 1. Only if this is satisfied can we say that a vector given by Li cap plus Mj cap plus Nk cap represents a unit vector in the direction of LMN. And it's a unit vector. Why? Because L square plus M square plus N square is 0. That's the definition of direction cosines. Coming to what direction ratios are. Direction ratios are nothing but any multiple of a direction cosine. So if I take any random number, let me denote it by lambda, lambda L, lambda M, lambda N, these are direction ratios, and the squares of direction ratios is not 1. Am I clear? Alright, let's take a vector 2i cap minus j cap plus phi k cap, and we have to find what the direction cosines of this vector is. We have learned that L is the angle the vector makes with the x-axis. So if I use a bar dot b bar is mod a mod b cos theta, and if I take b bar as I cap, I will get a bar dot mod a is cos alpha, which is L. So in this case, 2 by root of 4 plus 1 plus 25, which is 2 by root 30 is L. By same logic, M is minus 1 by root 30 and N is 5 by root 30, and these are the direction cosines of my given vector. Direction ratio for all practical purposes are 2, minus 1 and 5, where my lambda in this case I have taken it as root 30. The lambda can belong to any real number. So this represents a direction ratio. Again, minus 2, 1, minus 5. This also represents a direction ratio. I hope we are clear with what direction ratios and direction cosines are. A lot of the times I have seen students get confused about the definition of cosines and ratio. Cosines, the squares add up to 1. Ratios are any multiple of the cosines. Let's look at some problem based on this concept of direction ratios and direction cosines. I'll just refer to my phone for the problems. We have to find the direction cosines of two lines which are connected by the relation L minus 5m plus 3n equal to 0 and 7l square plus 5m square minus 3n square equal to 0. Now the question here is, we are supposed to find the direction cosines of two lines, but we are given only one equation. What does that mean? It only means that since the direction cosines are squares, the root of this equation will be the two direction ratios. But then how do we find that? It's quite simple when we simply write this as L is equal to 5m minus 3n. Whenever such questions are given where you have three variables and two equations, the best way to solve for this is express any one variable in terms of the other two and plug this into the other equation. So I will get 7 into 5m minus 3n the whole square plus 5m square minus 3n square, which is going to give me 7 into 25m square plus 9n square minus 30mn plus 5m square minus 3n square, and when I open the brackets, I will have 280m square (60n square) minus 30mn is equal to 0. And if I simplify this further, I have 28m square minus 6n square plus minus 3mn equal to 0. Now what do we do further from here? The way we do this is, we have to divide the expression with, sorry, I have made a calculation mistake here. 175 plus 5 is 180, and when I further simplify this, I can take 3 common. I have 6m square minus mn plus 2n square is equal to 0. Now I will take n square common, so I will get 6m by n the whole square minus m by n plus 2 equal to 0, and I will say m by n is equal to t. So this is going to give me 6t square minus t plus 2 is equal to 0. The reason I did not write the n square outside is because when I divide it by 0, I will get 0 and n cannot be 0, as one of the cases is what I have assumed here. And this can be simplified as 6t square minus 4t plus 3t plus 2 is equal to 0. So 3t plus 2 into 3t minus 2 I have made a calculation mistake somewhere. Let's find out where I have made the calculation mistake. Alright, I clearly am not able to find my error, but when you solve for this, you will get m by n as 2 values. So that gives me m1 by n1 is the solution to first value, and m2 by n2 is the solution to the second value. And how do you find L? Is by plugging in the equation back here. I'm sorry about that, but I have made a calculation mistake somewhere. Let's look at another type of question which comes in direction ratios and direction cosines. We have to find the angle between x minus 1 by L equal to y plus 1 by m is equal to z by n, and x plus 1 by m is equal to y minus 3 by n is equal to z minus 1 by L, and the relations given is L greater than M greater than N, and L, M, N are the roots of the equation x cube plus x square minus 4x minus 4 equal to 0. If we have to find the angle between these two lines, please understand that in this question, it is nowhere mentioned that L square plus M square plus N square is equal to 1. We don't know if they are the direction ratios or the cosines. But we know that if the equation of a straight line is given in the Cartesian form, then L, M, N here and M, N and L here represent the direction ratios of the line to which these are parallel, which will mean the angle between these two direction ratios are nothing but the dot product Lm plus Mn plus Ln divided by root of L square plus M square plus N square into 2. We are not sure if L, M, N are the direction ratios or the direction cosines. We have a equation here. So we know that the sum of the roots L plus M plus N is equal to minus 1 from Ln plus Mn plus Nl is equal to minus 4. Lmn is equal to 4 from theory of equations. And all we have to do is write this as minus 4 divided by square root, and square will become whole square. L square plus M square plus N square is L plus M plus N the whole square minus 2 times summation Lm, or product of the roots taken 2 at a time, which is going to be minus 4 by 1 minus 2 into minus 4, which is minus 4 by 9, and that is the angle between the two lines that are given. Let's understand about equation of a straight line in 3D form. We know that if I take the orthogonal plane of reference x, y, z, I have any point in space, then this is nothing but the position vector of A with respect to the origin. Let me take any other line given by L bar to which my line that I want to find is parallel. So right now I am trying to find the equation of a straight line passing through a point parallel to another given line. We know from the triangle of vector addition that OA bar plus any point on B, AB bar is going to give me OB bar. That's the triangle law of vector addition. But how do we find AB bar? If L bar is given, we know that L bar technically represents the line to which the vector AB is parallel. And if I do lambda times L bar, where lambda is an indication of the magnitude of AB. If my point B was not here, but let's say my point B was here as B prime, then my lambda would be more for me to take a larger distance. And lambda L bar is defining the position of B along AB. From triangle law of vector addition, I can simply state that A bar plus lambda L bar is nothing but R bar, or the position vector of my point B bar in vector form. So if I have to write the vector equation of a line passing through a given point A bar and parallel to another line B bar, this is the vector equation. If I have to write the same thing in Cartesian form, I am trying to denote B as x, y, z. I know that A is given as x1, y1, z1. The direction ratio of line AB is x minus x1, y minus y1, z minus z1. And since this is parallel to the line L bar, whose direction ratio, let me say, is given by ABC, I know the relation for two parallel vectors as this. And that is how you get the vector equation of a line passing through, Cartesian equation of a line passing through a given point x1, y1, z1 parallel to a vector ABC. If we had to find the vector equation of a line passing through 2 points, then I would say R bar is A bar plus lambda times B bar minus A bar, where B bar and A bar are 2 points because the direction ratio of the line joining AB is given by B minus A. And the same thing in Cartesian form could be written as and this is the Cartesian equation of a line passing through a point x1, y1, z1 parallel to the line joining AB. Now, this x1, y1, z1 could have been x2, y2, z2 for all we care because it wouldn't matter. We would eventually end up with the same straight line. Alright, this is what was used to find the previous question. Let's look at another question, interesting question that I came across. We have to find the internal angle bisector of angle ABC if AB is x minus 1 by 2 equal to y minus 2 by 3 is equal to z minus 3 by 4, and BC is x minus 1 by 3 equal to y minus 3 by 4 is equal to z minus 1 by 2. Now, let's try to visualize and imagine this. This is my AB, this is my BC, and we have to find the angle bisector of these two lines. Given that we have two lines, we can represent any point on AB to read 2 lambda plus 1, 3 lambda plus 2 and 4 lambda plus 3. Now, since this point will also lie on BC, we know 2 lambda plus 1 minus 1 by 3 is equal to 3 lambda plus 2 minus 3 by 4, which is going to give me 8 lambda is equal to 3 into 3 lambda minus 1. That is going to give me lambda is equal to 3. And once we have got lambda, we can plug it in to find my corresponding point, which is 7, 8, 15. So we know that point B is 7, 8, 15. Now, how do we find the direction ratio or the direction cosine of the angle bisector of angle ABC? We know that the direction ratio of AB is 2i cap plus 3j cap plus 4k cap, and the direction ratio of BC is 3i cap plus 4j cap plus 2k cap. The interesting point to note here is if we take unit vectors along AB and along BC, which will happen by simply dividing it with the magnitude and this by the magnitude, I have got two unit vectors along AB and BC. Sum of these two unit vectors is going to be the angle bisector of BC, and that's what we have to do. The angle bisector is going to be 5 by root 29 I cap plus 7 by root 29 j cap plus 6k cap by root 29. Now, do we have to convert this into a unit vector again? Not necessary, because I am going to use this with some other quantity lambda. These lambdas are not the same, plus the coordinates of B bar to get the vector equation of a line that is bisecting the angle ABC. So the interesting point to note here is if the question was angle bisector, we just have to take two unit vectors and add them, because the angle of in a parallelogram with two equal sides becomes a rhombus, and the diagonal of a rhombus bisects the angle, and that's what we have used here. The next interesting point to note is if you are given two vectors and we have to find a vector that is perpendicular to both, we will use the cross product of A cross B. We need not think that if my one vector is I cap minus j cap plus k cap and the other vector is 2i cap plus 2j cap minus k cap, then I will assume the third vector to be ai cap plus bj cap plus ck cap. Dot product with this is 0, dot product with this is 0. I get two equations, but I have three variables. Simple. You just do the cross product of these two vectors. You will get a vector that is perpendicular to both the vectors. And that's the beauty of vectors. If these 2 points are clear, let's go on to the next type of problem that comes in vectors, which is essentially distance between line and point, mirror image of point in line, perpendicular on a line from a point. Now, all these three questions are the same. Let's understand how. If I have a vector B bar which refers to the line in these cases, and I have another point A bar, right? The vector equation of the line B bar or this vector would be given as passing through a point A1 and parallel to another vector B bar. We have to find, for us to find the distance between the line and the point, we will have to consider the foot of the perpendicular from A onto B bar. I will denote that as P. Let's understand how this foot of the perpendicular solves for all of this. I can find distance between point A and point P. I will get the distance between the line and the point. Perpendicular on a line, I have found the foot. This is what it is. Mirror image of a point. Since I'm asking mirror image, the point P is nothing but the midpoint of A and its mirror image. So by applying midpoint formula, we can find the point A. X plus x dash by 2 is the x coordinate, y plus y dash by 2 is the y coordinate, and that's how all these three problems are the same. Let's understand two ways on how to solve it. If the vector equation of the line is given as A bar plus lambda B bar, I can convert this into a Cartesian form as x minus xa by L is equal to y minus ya by m is equal to z minus za by n. Now, any point xyz on this line, even the point P, can be represented as L lambda plus xa, and so these are the coordinates of the point P. Since we know the coordinates of the point P, we can find the direction ratio of AP as going to be xp minus, let me call this point Q to avoid confusion, xp minus xq, yp minus yq, and zp minus zq, and we have got the direction ratio of the line PQ. By doing the dot product of this, with the direction ratio of B, which is LMN. What I'm trying to say is this into L, this into M, this into N is equal to 0, the sum. We know LMN, ZQ, it's given. And for XP, YP, ZP, the only variable is lambda. So using this, we'll get the value of lambda, and when we substitute it back in my XP, YP, ZP, we have got P, and then we can solve any of these questions that is given. Let's see another way of doing the same question. Let's say this is point B. I have a point A bar and I have taken point Q bar. I need this perpendicular distance for me to find the distance. From the vector equation of the line or the Cartesian equation of the line, I can find what the distance AQ is, because A is known, Q is known. I can find the distance AQ. What I'm trying to say is AQ dot B cap is going to be equal to AP, the distance AP, right? And then we can simply apply our Pythagoras theorem and state that AQ square minus AQ dot B cap square is equal to PQ square, and that's how we also get distance between point P and Q, or the distance of the line Q, point Q from the line D. This is another way of solving it. It depends on what the problem is asking you to do and where your calculations become simpler. Product and arithmetic, use this. If you want to find the point and work with the point, then go ahead and use the other approach. The one place where I have seen students make mistakes is in questions like this. Now, through what point does the line pass? The line does not pass through 2, 2 and minus 5. We have to ensure that the coefficient of x, y and z is 1. Let me take this as 2. So I will first take minus 3 common and write it as x minus 2 by 3 by 5 equal to y minus 2 by 3 is equal to 2 into z plus 5 by 2 by minus 9. And then I will take this minus 3 to the denominator and write it as x minus 2 by 3 by minus 5 by 3 is equal to y minus 2 by 3 is equal to z plus 5 by 2 by minus 9 by 2. My direction ratios are minus 5 by 3, 3 and minus 9 by 2, and the point is 2 by 3, 2 and minus 5 by 2. Please don't make this mistake in a hurry where the coefficients of x, y, z are not 1 and we have to convert it to 1. Let's look at another type of question that will come, right? We have to find the distance of 7 minus 2, 11 from the line x minus 6 by 1 equal to y minus 4 by 0 is equal to z minus 8 by 3 along x minus 5 by 2 is equal to y minus 1 by minus 3 is equal to z minus 5 by 6. Let's try to visualize this question and then see what all we have to find. So we are given a line x minus 6 by 1 blah blah blah. So it passes through 6, 4 and 8, and we know that its direction I cap plus 3k cap. We are given some point 7 minus 2, 11. If we had to find the perpendicular distance, we would have done this. But we are given another line that passes through the point 5, 1 and 5, and we have to find the distance of this line, this point from this line along this. And that's where this question gets a little tricky. Let's understand how we have to do this question. We know that the direction ratio of the second line is 2, -3 and 6, right? We can also find any point on this line in terms of lambda, which is going to be lambda plus 6, comma 4, comma 3 lambda plus 8, right? We have found this. Now, we also can say that the direction ratio of the line joining this some random point Q to our given point A is AQ, which is the difference of this. But this is parallel to this. So if two lines are parallel, their direction ratios are proportional. So all I have to do is find the direction ratio of this in terms of lambda, and then do this by 5 equal to 6 by 1 equal to 3 lambda plus 8 minus 11 by 5, or lambda minus 1 by 5 is equal to 6 by 1 is equal to 3 lambda plus 3 by 11, and solving we will get lambda is equal to 31. And that's how you solve. You will plug it back into the equation, you will get the point, and you have to then find the distance of AQ. The trick here was that it was not the perpendicular distance, and that's why it was becoming a little bit of a concern. I hope this question is also clear for the two of you. Let's discuss about one last type of question that usually comes in this topic, which is distance between two lines. But before we do that, let's understand how two non-parallel lines in vectors may not intersect. If I have this as one, if I have my right arm as one of the lines and my left arm as the other lines, clearly these two lines are not parallel, yet they are not intersecting because both the lines are not in the same plane, and such lines are called skew lines. We will be given the equation of line 1 A bar plus lambda B bar. We will be given the equation of the other line as T bar plus lambda Q bar. The way we find the distance between the two lines is by finding the perpendicular distance. So what we have to do is we can take any point x on this in terms of lambda 1, and we can take any point y on this in terms of lambda 2. So we will take a point x and a point y on both these lines and join them. So we have got the direction ratio of the line xy by subtracting the coordinates, and we have that in terms of lambda 1 and lambda 2. Now for me to find the distance is the shortest when these lines are perpendicular, and by logic, the direction ratio of x dot b should be 0, the direction ratio of xy dot q should be 0, and we have two equations and two variables lambda 1 and lambda 2. By solving for this system of linear equations, we will get lambda 1, lambda 2, and hence x and y, and then we can use distance formula to find the distance of xy. So this is the usual way of solving these questions, but let's look at something that is a little more interesting. I am doing this dotted to indicate that they are not crossing each other. I have point A and I have point P. I have to find the perpendicular distance on these two lines, right? So what I can do is I can find AP as my length of AP or the vector AP as this vector. Now I know that this perpendicular, let me call it by P dash, is perpendicular to both L1 and L2, right? But L1 has the direction ratios of B bar and L2 has the direction ratios of Q bar. So perpendicular bar will have the direction ratio of A bar cross B bar cross Q bar. Are you with me so far? This I have got the direction ratios of perpendicular bar, and my unit vector is going to be equal to with me. Once I have got this, what I'm going to do is, for me to find the distance, I'm just going to do AP bar dot of perpendicular cap, which is AP bar dot B bar cross Q bar by mod of B bar cross Q bar, which is nothing but box of AP B Q divided by mod of B bar cross Q bar. A lot of students had asked me about that dirty looking formula that will be given as x1 minus x2, y1 minus y2, z1 minus z2, a, b, c, p, q, r divided by your cross product, which is br minus cq plus minus ar plus c, and that thing, right? I never really enjoyed or liked this formula because I was not able to understand the logic behind the formula. But today, I've been able to visualize and understand where this formula comes from, and hence you may use this formula if you understand the logic, because once you understand the logic, you don't need to memorize this formula and you can actually derive the formula in the exam. The challenge happens when you have two planes that are parallel to each other and you have two lines on those planes. The lines are also parallel. In that case, it will not be B bar cross Q bar because both of them are parallel. It will simply be AP dot B bar by mod of B bar. And that's how you find the distance between two lines which are parallel. I hope this was a useful session. What I would like to hear from you folks is if there are any doubts that you people are encountering or envisioning for me to help you with solving. Please go through the questions I have presented so that you are able to practice them and come back to me with any doubts. Do like, share and subscribe to our channel, and drop in the comment section below on any other topics that you would like me to pick up. I will soon come back with planes. While plane is deleted from the syllabus, there are questions that can come and it's always a good to know part of the syllabus.